Did you notice that suddenly the whole world started talking about Three-Eye Atlas again? That's right. China has just released new data on this mysterious interstellar visitor, and what's written in this report is putting the scientific community on alert. But there's one detail that nobody wants to comment on. The most important parts of the document have simply vanished. The official report states that nothing changed, and yet everything changed. A curious, ambiguous, and for many, suspicious phrase, because while the released data seems to confirm what we already knew, there are indications that the Chinese government might be hiding unprecedented observations, results so out of the ordinary that they have not yet been publicly released. After all, why would a country that recorded the rarest event of the decade decide to reveal only part of the story? Astronomers are divided. Some believe it's just scientific caution, others that there's something much bigger behind it, perhaps a discovery the world isn't ready to understand yet. The fact is, during the 36 hours when the rest of the planet was blind, only China kept its telescopes on, capturing data that no other country possesses. And now everyone wants to know the same thing. What exactly did they see? Stay with me until the end, because today I'm going to show you what the Chinese report really says and what it seems to be avoiding. We're going to analyze what's between the lines, the omissions, and the clues that might reveal the best-kept secret of modern astronomy. But before we start, go ahead and leave a like, subscribe here to the channel, and comment down below. Do you think China is hiding something about Three-Eye Atlas? Nobody expected that something coming from another solar system would cross our path so suddenly. When Three-Eye Atlas was first detected, it seemed like just another point of light lost among millions, but it only took a few hours of calculation to realize it didn't follow the known rules. Its trajectory was hyperbolic, meaning it wasn't bound to the sun. It came from far, far away and would pass by only once before disappearing forever. For many astronomers, it was like witnessing a letter written by another star. These objects, known as interstellar visitors, are fragments of worlds that formed in completely different places. They carry in their ice and dust the fingerprints of other suns. The first of them, Oumuamua, intrigued the world in 2017. The second, Borisov, confirmed that we weren't alone in this type of visit, and now Three-Eye Atlas emerges as a third message, perhaps the most enigmatic of all. But what makes this object so special isn't just its origin, but its behavior. While common comets shine with water vapor as they approach the sun, Three-Eye Atlas remained cold, mysterious, almost indifferent to the heat. This made scientists scratch their heads. How could a body made of ice resist like that? The answer, it seems, lay in its completely non-standard composition. Each new measurement reinforced the same unusual pattern: almost no water, but a huge abundance of carbon dioxide. In other words, this visitor was born in a radically different environment from ours, a place so cold and distant that carbon froze before water did. This in itself is already a gigantic scientific finding, direct proof that not all planetary systems follow the same recipe for life. And this is where the story starts to change its tone, because just when Three-Eye Atlas reached the closest point to the sun, the moment it would reveal its most precious secrets, something unbelievable happened. When Three-Eye Atlas approached the brightest point of its trajectory, the planet's largest telescopes were preparing to record the event. It was the ideal moment to capture valuable data about its composition and behavior. But unexpectedly, a sequence of technical coincidences plunged astronomy into absolute silence. In a matter of hours, Hubble went into maintenance, the James Webb began an instrument swap, and the Very Large Telescope in Chile started a mirror cleaning cycle. Each of these pauses made sense on its own. None of them seemed suspicious or out of the ordinary, but added together, they created an unprecedented gap. For the first time in decades, practically all major Western observatories went blind at the same time. While the comet passed through its point of greatest activity, there were no eyes pointed at it. Astronomers realized the problem too late. The interstellar visitor was crossing the sky without witnesses. For 36 hours, crucial data was not collected. The absence of continuous observations interrupted the recording of the light curve, preventing scientists from tracking the pace of changes in the object's nucleus and coma. In practical terms, it was like losing the central pages of a book you could only read once in your life. 3i Atlas would not return, and without this information, part of its story would remain incomplete forever. Behind the scenes, there was a race against time. Teams tried to coordinate smaller telescopes to fill the gap in the data sequence, but the solar glare was already obscuring the region of the sky where the object was located. The position of 3i Atlas made it practically invisible to common equipment. The largest observatories, ironically, were programmed not to look precisely where the universe was speaking. The silence that followed was technical, but also symbolic. The limit of our dependence on a few centralized structures. When the large telescopes finally returned to operation, 3i Atlas had already advanced millions of kilometers on its escape route. The observation window had closed. It was too late to recover what was lost, but not to learn from the mistake. In another part of the planet, a group of much smaller telescopes had kept their lenses active, and what they captured would completely change the course of this story. While much of the planet awaited the return of Western telescopes, a set of discrete observatories installed in the mountains of Tibet, Qinghai, and Yunnan continued to operate in silence. These telescopes, smaller and lesser known, belonged to the Chinese Automated Astronomical Monitoring Network. They were medium-sized instruments between 2 and 4 meters in diameter, but with one advantage. They could work continuously and in a synchronized manner without depending on large teams or operational bureaucracies. The geographical conditions of these locations are unique. The high altitudes and extremely dry air offer superior atmospheric transparency, ideal for capturing faint light from distant objects, and it was exactly during those 36 hours of the global blackout that these observatories kept their lenses pointed at 3i Atlas. While the world's largest telescopes were out of operation, the Chinese mountains were recording every second of the interstellar visitor's passage. The images were captured with millimeter precision. Each exposure lasted between 30 and 120 seconds, enough time to balance brightness and motion. The object's high speed required continuous automatic adjustments, calculated by real-time tracking software. Nothing was left to chance. Even the smallest synchronization error could generate blurs or data loss. But the system remained stable, capturing hundreds of consecutive frames. All records were saved in FITS format, the international standard for astronomy, which stores not only the image but also the metadata, coordinates, filters used, ambient temperature, and the exact time. Each file was sent via fiber optics to redundant servers in Nanjing and Beijing. This transmission chain, nicknamed Eyes Under Ice by the engineers, allowed the data to be kept intact even at temperatures below zero. When the digital dust settled, China possessed something the rest of the world did not: the complete and continuous record of an interstellar object at its most critical observation point. The silent attention of these mountains had captured what no one else managed to see. The collection of data was just the beginning. The real achievement was the technical quality reached with instruments considered modest. The secret was in the automation. While the large observatories needed long calibration periods and entire teams to adjust their optical systems, the Chinese network operated by algorithms that redistributed tasks as the weather and visibility changed. Each telescope, upon noticing increased clouds or thermal variations, automatically transferred the observation to another, ensuring total continuity. These handoffs were managed by internal software called SkyBridge, developed by engineers at the National Astronomical Observatory of China. The system was capable of evaluating in real time which telescope had the best angle and the most stable conditions. The network acted like a living organism. When one station closed its eyes, another opened them immediately. This uninterrupted coordination produced a data sequence so clean that astronomers could track 3i Atlas with 10 times the precision initially estimated. Each pixel of the images was calibrated using known reference stars called Landolt standards, which ensured the uniformity of the results. The brightness measurements were adjusted based on the Sloan Digital Sky Survey, one of the world's largest calibration libraries. Even the spectral lines used to identify the gases and elements present in the object's coma were corrected with thorium and neon lamps. ensuring results comparable to those obtained by Western telescopes. The Chinese scientists knew that any discrepancy would be subject to international scrutiny. Therefore, they documented every step of the process, from optical adjustments to the statistical filtering of noise. The level of technical transparency surprised even the most skeptical experts. What could have previously been considered a secondary collection became the most reliable record of an unrepeatable phenomenon. In the end, the Skybridge network had shown the power of decentralization. Instead of depending on a single giant telescope, dozens of smaller, perfectly coordinated eyes produced a continuous, detailed, and resilient view. And this changed the way the world began to see the value of distributed astronomical observation. When the Western telescopes returned to operation, 3I Atlas was already far away, more than 1,000,000 kilometers ahead on its escape route. Without China's observations, astronomers would have lost the trail, but the data collected in the mountains allowed them to recalculate its trajectory with extreme precision, reducing uncertainties that, without it, could have made future analyses unfeasible. In other words, the Chinese observations saved the continuity of global research. When shared with the rest of the scientific community, the data showed something surprising. During the blackout, the brightness of 3 Atlas increased by about 1/3 of a magnitude. This variation indicated internal activity, probably a jet of gas and dust expelled from its nucleus. Furthermore, the spectral analysis revealed particles of pure carbon and rare compounds, confirming that the object originated from a chemical environment completely distinct from our solar system. These results were independently verified by teams in Hong Kong and Taiwan, who confirmed the precision of the numbers within minimal error margins. The final report, jointly signed by Chinese and international institutions, established a new standard for scientific collaboration. For the first time, the most important data from an astronomical event came not from the planet's largest telescopes, but from the most persistent ones. The episode showed something essential about the nature of scientific discovery: the value of being present when the universe decides to reveal itself. Constancy beat capacity. Patience overcame the size of the mirrors. The world realized that knowledge depends not only on technological power, but on coordination, preparation, and continuous vigilance. And so 3I Atlas transformed not only into an astronomical landmark, but also into a symbol of a new era of global observation, decentralized, collaborative, and tireless. From the beginning of the analyses, something about 3I Atlas intrigued scientists. Unlike any comet ever observed in our solar system, it exhibited a composition with practically no water. Instead, its nucleus ejected enormous quantities of carbon dioxide, forming a thin mist of dry ice in space. This characteristic made it a cosmic exception. Almost all known comets release water vapor when heated by sunlight, but this one seemed to completely ignore the expected behavior. The collected spectra showed clear emission lines of carbon, oxygen, and traces of organic compounds, but none of the H2O that usually dominates this type of observation. This led researchers to a fascinating conclusion: 3I Atlas must have formed in an extremely cold environment, farther from its star of origin than Pluto is from the Sun, a place where carbon dioxide ice is common and water, paradoxically, is rare. This chemical difference is a valuable clue about the diversity of planetary systems existing in the galaxy. If we think about it, this type of material reveals the DNA of other worlds. Each element, each molecule frozen inside a comet, tells a piece of the story of the place where it was born. The fact that 3I Atlas is dominated by carbon suggests that its host of the star may have had a formation disk rich in heavy elements but poor in hydrogen. In simple terms, it's a direct window into another type of cosmic chemistry, one that doesn't follow the same rules that shaped Earth. The light samples collected also showed large particles, denser and darker than the common dust from local comets. This characteristic indicates that its material may have been exposed to long periods of interstellar cosmic radiation, hardening and darkening its surface. It's as if the object carries scars from a journey of millions of years between the stars, crossing regions where the sun is just a distant point and the cold borders on absolute zero. For astronomers, 3-Eye Atlas is more than a scientific curiosity. It's a physical message sent from another solar system, a natural sample of alien matter that passed close enough to be studied. Each new analysis of this visitor expands our understanding of how planets form, which elements are most abundant in other regions of the galaxy, and even where life might exist. And the most notable part, these answers came thanks to a sequence of observations that the entire world almost missed. When China released the final report on 3-Eye Atlas, the document drew attention not only for its content, but for its tone. It was direct, technical, and unusually concise. Instead of announcing a major discovery, the text limited itself to confirming previous observations, as if nothing new had been found. However, a specific sentence sparked curiosity in researchers around the world. Nothing about the object changed, and yet everything changed. This choice of words is not common in scientific communications. Normally, reports of this type are limited to data and error margins. Here, there was something more. A note of reflection, almost philosophical. Why would an official statement use such ambiguous language? Some astronomers suggest the text may have been translated in an intentionally neutral way, avoiding the revelation of details that are still being analyzed. Others believe this brevity indicates the existence of more complex results, kept secret until internal confirmation. Some recall that China has a history of publishing scientific results in stages. First, they present the essentials. Then, months later, they release the complete analyses. This wouldn't be unprecedented. But the timing, right after the global blackout, gave the situation a different tone. After all, while the rest of the world was in the dark, China was the only country that maintained uninterrupted observations. And now complete control of the information was in their hands. Many Western researchers tried to access the raw data directly, but the files were only partially released in compressed formats and without some of the original calibration tables. Small details, yes, but enough to hinder independent verification. What else could be stored in the complete versions of the records? This question echoed for weeks in forums and astronomy conferences. While the scientific community awaited answers, a sense of unease grew. No one doubted the authenticity of the measurements, but there was something between the lines. An omission, perhaps, or a discovery whose interpretation was not yet ready to be announced. After the release, some independent observatories tried to compare the Chinese numbers with predictive models based on previous observations. That's when subtle discrepancies emerged. Small differences in the brightness variation and the estimated size of 3-Eye Atlas's coma began to attract attention. In internal reports from ESA and North American universities, astronomers reported inconsistencies of up to 5% between the expected values and those presented in the official charts. These differences in isolation do not mean fraud. In astronomy, variations of this type are common due to differences in calibration. The problem is that in this case, the Chinese data was the only data available during the crucial period. Without other sources to compare, any discrepancy becomes impossible to verify. And this raises an uncomfortable question: to what extent can we confirm what really happened in that 36-hour interval? Some scientists believe the object exhibited behaviors that have not yet been disclosed, such as abrupt changes in direction or thermal fluctuations incompatible with traditional comets. Others speculate that the raw data reveals something that challenges the current consensus on interstellar bodies, and that the Chinese government chose to keep it under review until they fully understand the implications. In discreet interviews, members of the technical team in Beijing stated that there is more material to be analyzed, but did not detail which aspects require review. This type of stance is common in highly complex projects, but it also fuels rumors. After all, when the rest of the world depends on a single set of observations, any silence sounds like a secret. The most curious point is that despite the mystery, China has not denied requests for collaboration. On the contrary, it invited foreign scientists to visit its observatories. But so far, no additional data has been publicly released. What exactly is being reviewed, and why so much care with something that supposedly nothing changed? Among the hypotheses raised, some are more plausible than others. The first and most accepted is that the Chinese team detected unexpected chemical variations, perhaps signs of complex organic compounds which are still being validated to avoid hasty interpretations. In science, an announcement of this type requires triple verification. The second hypothesis is more technical, that part of the spectral data revealed unusual light patterns difficult to fit into known models of light reflection and emission. There is, however, a third hypothesis that sparks more speculation, that 3Y Atlas exhibited artificial emissions, signals that cannot be explained by natural processes alone. None of this has been confirmed, of course, but the mere possibility makes the institutions involved act with extreme caution. No country wants to publish something that could be interpreted as evidence of non-natural activity without a solid basis. While the debates continue, the Chinese silence remains. Beijing states that the data is under technical review and that new results will be released at an appropriate time. This careful stance can be read in two ways: scientific prudence or strategic control of information. The line between the two in this case is thin. What is certain is that there are more questions than answers. If the Chinese really detected something beyond the expected, whether a new chemical compound, anomalous behavior, or just an instrumental error, the impact will be immense. After all, we are talking about an object that came from another stellar system, a fragment of matter that carries within it stories from billions of years, and maybe, just maybe, part of that story is still being kept under lock and key. What 3I Atlas taught us goes far beyond astronomy. It showed that the universe still holds secrets that are not revealed to the most powerful, but to the most attentive. That the biggest telescopes don't always see the furthest, and that sometimes the persistent gaze of those who don't look away is what changes history. The interstellar visitor passed, but what it left behind was a mirror, a reflection of how humanity observes, cooperates, and competes in the face of the unknown. If there's one thing the scientific community learned from this event, it's that knowledge needs to be shared. The stars have no owner, and the cosmos belongs to no flag. Scientific truth must circulate freely, because only then can we connect the fragments of information that each country, each telescope, and each researcher captures. 3I Atlas showed that when one side of the planet closes its eyes, the other can and must keep looking. But a doubt also remained in the air. What else do we still not know? The Chinese report was clear and enigmatic at the same time, perhaps out of caution, perhaps out of strategy, and that is precisely what keeps the flame of human curiosity alive. Science is born from mystery, from doubt, from the restlessness that makes us keep observing the sky even when no one else is paying attention. Whatever 3I Atlas brought from its home system, one thing is certain. It reminded us that there is still much to discover, and that the next great revelation could happen at any moment, anywhere, by someone who simply decided not to blink. Space doesn't wait, and neither does knowledge. If you've made it this far, thank you so much. Now tell me in the comments, do you think China might be hiding something really important about 3I Atlas? I want to know your opinion. And don't forget, like the video, subscribe to the channel to follow our next investigations into the universe, and activate the bell so you don't miss anything. See you in the next video. And until then, keep looking up at the sky. It always has something new to tell.